All right, guys, I forgot to record this video to the last second, so we're gonna have not the best quality here, not the best angle, but I gotta record from my computer so I can upload this quickly so you have your videos for the week. So I wanna take another look at limits as we're approaching infinity and applying L'Hopital's rule to these types of questions. So I've got two problems up here. In the first one, we have the limit as x approaches infinity, and in the top, the biggest exponent is that x to the third, and the bottom is the x to the fourth. So we actually have now three ways that we can do these types of questions. First, we could memorize that if you have a degree that's larger in the denominator, as you approach either positive or negative infinity, it's going to equal 0. Now, that would be one option. But if you forget that property, so I want to try to apply two other ways that we could solve this question here. So we could ignore everything that's not the biggest exponent in the top and the bottom. So we can ignore the minus 4x squared to the minus 1. And we could simplify this here. And if we simplify this expression, the top just becomes 2, the bottom becomes x. And now if we plug in that infinity, we get 2 over infinity, which is 0. All right, so that would be the second option of how to get 0 for this one. The third option, if we just take these and we plug in infinity, we're going to get infinity over infinity, which is indeterminate. And so what we can do is apply L'Hopital's rule to just the highest order terms here. So if I do L'Hopital's rule one time, I would get 6x squared on top over 4x cubed on the bottom. Now if I plug in infinity, I still get that infinity over infinity. So if I did it a second time, this would give us 12x over 12x squared. You cancel out the 12s. If I plug in infinity, now I still get infinity over infinity. And then lastly, what would this give us? 1 over 2x. Well, now if I plug in infinity, I get 1 over infinity. And that would give us 0. So L'Hopital's rule may not be the fastest method, but it does still apply. You can do 3 derivatives here and then plug in the infinity, and you still do get 0 for this question. All right, next question. So x is approaching infinity, and our degrees are the same. All right, I'm going to do the second option for this one. So let's get rid of these two terms and those two terms, and let's simplify. Well, this simplifies into the limit as x approaches infinity of the x squareds are going to cancel, so we have a 4 on top and a 12 on the bottom, or just 1/3. Now there's nowhere to plug in that infinity, so again, it's just 1/3 would be the answer to that question. Now, could I have done L'Hopital's rule? Yes, this is infinity over infinity, so I could take a derivative to get 8x over 24x, and then take a second derivative to get rid of the x's, just get 8 over 24, and that also simplifies into 1/3. All right, so really whatever method you prefer, both of those work just fine. Now, this next question, we've got the limit as x approaches infinity of e to the x over x to the 50th. So if we were to plug in infinity, e to the infinity, that's 2.7 times itself forever, that would give us infinity. In the bottom, it would be infinity to the 50th. Well, that's just infinity. So we do get infinity over infinity, and we have to apply L'Hopital's rule on this one because it's not a polynomial on top. So we're going to have to do this with L'Hopital's rule. So applying L'Hopital's rule, we take a derivative of the top and the bottom without using the quotient rule. So e to the x is still e to the x. X to the 50th is 50x to the 49th. Now if we try plugging in infinity again, it's still e to the infinity, which is infinity, divided by 50 times infinity to the 49th, still infinity in the bottom. All right. In fact, we're going to have to take another 49 more derivatives before we can come up with an answer. And so we don't have to do those all in one. We can just, or all individually, we can just recognize that eventually the bottom is going to become a very large number. That's going to be 50 times 49 times 48 times 47, So it's 50 factorial on the bottom. and the top is just e to the x. Now if we plug in that infinity, we get e to the infinity over a number. So it's infinity over a number, which is just infinity. All right. If this had been flipped, if the e to the x was on the bottom, now it would have been a number over infinity and it would have turned into 0. All right. So that's it for this. Again, limits at infinity. We got a few options. If they're both polynomials, we have a few ways to think about it. But if one is not, we're going to have to do L'Hopital's rule. And this really is just recognizing, hey, we would have to do 50 derivatives before one of these two things is not infinity. All right, that's it, guys. Stay flawless.